Hi, I'm Dr. Hackey Reitman. Welcome to another episode of Exploring Different Brains. And today I'm honored to have the neurobiologist and the neuroevangelist all the way from the University of Chicago. And we have with us today Peggy. Peggy, introduce yourself properly because I'm being too informal.
Okay, so my name is Peggy Mason. I'm a professor of neurobiology at the University of Chicago. As Hackey said, I am a neuroevangelist. I think neurobiology is the lens through which life looks the rosiest, the most interesting and the rosiest. Yes.
Well, that's a good way of putting it. How did you get into neurobiology?
Um, I realized somewhere late in college that I actually had to get a way to make a living, and I thought, oh, I'd like to go to graduate school. I'd like to learn something more. I like this student thing, and I looked around, and I'd always been very interested in neurobiology. I had seizures as a kid. That was sort of interesting, horrible, interesting to me. And I'd read Oliver Sacks somewhere along the lines. I actually don't remember when I started reading The Man Who Mistook His Wife for a Hat, but that was very intriguing to me. And the intersection of neurobiology with why people do what they do, that sort of always interesting people watching question, it intrigued me in a way that, how does a heart or a lung work has never particularly intrigued me. So I find the nervous system endlessly fascinating. And I actually find the behavior of animals as fast as other animals besides humans as fascinating as the behavior of humans. So, I can get lost in my cat's behavior as well. And my original study was in ethology, which is the study of animal behavior, usually accepting humans as though humans are not an animal, which they are, but nonetheless.
Well, reading over your resume, it's quite a journey you've had. I mean, being the slacker that you are to go to Harvard of all places for all your degrees, and then go to the Smithsonian for, am I correct? It was taxidermy?
Well, I started in a taxidermy as a single digit child. So my mother and I, from the best that we can reconstruct it, I think I started around 7.
Wow.
And before I was 10, probably by the time I was 9, possibly 10, I was teaching because I'd taken it too many times. And so the instructor, who was Charles Handley Jr., who was the curator of mammals at the Smithsonian, just said, Peggy, come help me teach. So I did. And I loved it. And taxidermy is a skill. It's a skill that Darwin had. And anything I can do to ever emulate Darwin is good in my books.
The evolution and survival. Tell us about your journey from pain to empathy.
Yeah, so the pain field was really interesting. I did most of my work, my postdoc work was around a very dominant theme in the pain modulation field, which is how does morphine work? And that obviously has some applicability to the biomedical enterprise. But I took it in a slightly different direction. And I said, well, what does this pain modulation business do for a behaving animal? And so we were looking at conditions, behaviors actually, where an animal's receptivity to noxious stimulation was modulated. And I'll give you my favorite example. This was work done by Madeline Baez, which is that for the 6 seconds that a rat takes to urinate, the rat is insensitive to pain. And that operates through the same pathways that morphine analgesia acts. So that was really fun. And we also looked at food consumption. So while you're chewing, the rats are pretty insensitive. And this holds true actually for babies. So it's nice to see the parallels that others have reached. Pain is an interesting perception because it was the perception where empathy research first focused. So in other words, I can see another individual in appearing to experience pain and experience something akin to pain myself. So if you've ever seen somebody be injured, there's that cringe. Nothing's happened to you, and yet you are feeling a piece of that other individual's experience. And in 2006, Jeff Mogul from McGill University published a paper showing that mice in the presence of other mice who were also exposed to noxious stimulation felt more or expressed more pain behavior than if they were alone and given the same stimulus. So this was an example. This is an example of empathy, a very rudimentary form of empathy, but nonetheless empathy. And Science actually, the article was published in Science. I was asked for a comment on it. I don't know why. I think probably because my postdoc advisor refused to comment on it and sent them to me, something like that. And I said, well, this is emotional contagion. It's not really empathy. It's akin to when one baby cries in the nursery, all the babies cry. Science published that quip. And then Scientific American Mind asked me for a blog entry. And they liked the blog entry, so they ended up publishing that in Scientific American Mind as a commentary on a longer piece by Franz de Waal. So, and then I never thought about empathy again until I believe it was late in 2007, when Inbal Ben-Ami Bartal, at that time a graduate student in Jean de City's lab here at the University of Chicago, and now actually an assistant professor at the University of Tel Aviv running her own lab. So Inbal approached me because she's seen this quote and thought I actually knew something about empathy, which I didn't at the time.
You're very humble. You're very humble.
So, and she says, would you like to collaborate? I'm interested in I've been doing research on human empathy, which is Jean's expertise. And I actually want to get back to rodents. I want to look at the biological basis of empathy. And I jumped at the chance because I had always found this empathy, your ability to perceive pain without ever experiencing pain, to be an incredibly interesting and attractive concept. So I said, yeah, let's talk. And within a couple of weeks, she was in the lab and the three of us were doing this collaboration, and we ended up with this robust paradigm where one rat will help another rat who's trapped. And it's an arena that's about 1.5 feet square. And the rat is 1.5 feet cubed, actually. So the rat is a free rat is placed in there, and the trapped rat is placed in a plexiglass tube that we call the restrainer, that's placed in the middle. And the free rat can just ignore this trapped rat. But what we found was that the free rat was very bothered by the trapped rat, bothered enough that they left the safety and attraction of the walls of the arena, which is where rodents like to be, to go into the center and open the door for the trapped rat.
Wow.
And, if they do that once, it's kind of who cares, but the next day they did it again. And by the third day, they never missed, every once in a while, a rat would do it once and not do it the next day. But once they'd done it twice in a row, they invariably, or over 98% of the time, they did it the third time.
Wow.
And each day that they did it at a shorter later latency. And we studied them over the course of 12 days. And over the course of 12 days, they got down to a latency on the 12th day that was 0 or very close to 0. They just get in there and open the door.
Wow.
So this is what we would call a very reinforced behavior. And we know more about that now. We do know that it's heavily reinforced. This is something, and what gets reinforced? Things that are enjoyable, things that are rewarding, things that feel good. So that tells you a lot about how helping feels to a rat. And we can read into that feels to a mammal. So that's a big lesson. It's a huge lesson. You are not helping because you went to Sunday school, or because you went to, or because
You're doing it because it makes you feel good.
Yeah, you're doing it because it feels good. And evolution has allowed this to, or evolution has advantaged this process, because it not only feels good, but it feels good because it renders selective advantage to those that help, those who form a cohesive group.
And I was just thinking myself, which parts of the brain are being used when they're experiencing this and changing their activity.
So Inbal just published a paper in eLife that does the first deep dive into the brain pathways responsible for this behavior, for the helping behavior. And most emphasized, and probably most important in this, is that there's activity, and in fact, dopamine release that occurs in nucleus accumbens. Now, nucleus accumbens is a very, I would say, popular fame as the reward center. And, that's not the articulation that is my favorite. My favorite would be that this is a place that that biases you towards or away from certain movements and certain actions. So it biases you towards actions that in, for want of better words, that feel good, and that you then crave to do again because you want to feel good again. And it biases you away from actions that don't have that beneficial effect. So accumbens is involved in addictive behavior that animals, including humans, exhibit towards drugs of abuse, heroin, alcohol, cocaine, etc. And so what happens is that it feels good, and that motivates the animal to then want to seek to do that again. And that's really what, it's not so much a state of nirvana or a state of reward. It's a state of craving. I want to feel that good again. It's going to be a momentary feel good, but I want to get to that place again. So craving, I really think of accumbens as mediating craving more than anything else.
Well, it probably has a lot to do with what makes social media tick.
Oh, 100%. The timing of this is on the time scale, on the sort of cue to reward time scale that matches dopamine release beautifully.
It reminds me of a discussion I had with one of our neurodiverse interns who's autistic and very, very smart, and a lot smarter than I am. And I said, look, I want you to learn how to, when you go to an interview, remember that the person who's interviewing you is going to be insecure like most people are. And you're very, very smart. So I want you to smile because that makes people relax and makes them feel good. And he told me just straight up, he says, I'm not doing that because it's not authentic. And I said, well, wait a minute. When you do something nice for somebody else, you make the happy chemicals, but also the other person gets it. So you'll be making me happy by you smiling. And guess what? You yourself will be happy. So he bought it. It was,
I mean, I think it's perfectly good advice. I would ask him whether he can sustain it. So something, because of the inauthenticity, essentially,
yeah.
I would bet that he has a hard time remembering to do it.
I'm going to find out. I'm going to ask him that question.
It's a put on. It's not coming from him. It's an added thing, and it's hard to make a habit of something that
No,
doesn't actually.
But I don't know if it
reward
gets.
you.
I don't know if it gets translated into becoming a rewiring of your brain. For instance, I once heard a podcast with this married couple, and the male was Asperger's and the female was neurotypical, if there is such a thing. And she was saying how when she would get home from work, he wouldn't say anything. And then she trained him kind of, why don't you make a pot of tea? And when I come home, we'll have some tea. And you can ask me how my day was, and then I'll tell you. And so she said, I'm just repeating what she said, that he started to do it robotically, but then he actually became interested in what she was doing. So
No, absolutely. You can train people to do things, but if it is not something that comes from the self originally, you do have to train.
Yes, you do have.
It's just, somebody telling me you should rub your right ear every time you enter the den, or every time you enter your office. I'm never going to remember that. I don't care about rubbing my right ear unless somebody is there every day. Did you remember to rub your right ear? Did you remember
or if rubbing your right ear makes the happy chemicals for you.
Well, in that case, then you don't need the reminder.
Right.
So you either need it to be authentic, it's serving some internal reward for, it's feeding into internal pathways that make you crave to do it, or you have to work and train to do it.
Right.
And you can, with enough training, make it habitual enough. And in fact, that's another thing that's remarkable about this helping behavior. And this is not published work, but Danny Levine, who was a medical student, is now a resident, examined at what point helping becomes a habit. And basically at the earliest point that we did test, it was already a habit. So let me explain what a habit is. A habit is something that's outcome independent. In other words, I shoot up heroin and it feels really, really good. So the next day I shoot it up again because I really crave that good warm feeling and it feels good. And I do it a third day and a fourth day. By the 100th day, the 10th day, maybe the 10th day, certainly the 20th day, it doesn't feel that good. It either feels neutral or it feels bad. Now, but I still do it. Why do I do it? Because it's a habit. It has transferred from being dependent on that warm, glowy feeling to being an action that is done habitually. Now, habits are good because they're fast. So when I brush my teeth, I use a habitual form of brushing my teeth, which is why I always laugh at these dentists. If you ever switch dentists and some new dentist tells you some new way to brush your teeth, good luck. That's not neurobiological, not neurobiologically accessible. Not going to happen. We brush our teeth through habit. We've been doing it a million times through our life. So these rats, they'll only learn to or develop the action of opening the restrainer if there's a trapped rat in there. But once they've done it twice in a row, if we now replace the restrainer with an empty, the restrainer containing a trapped rat, replace that with an empty restrainer, they still open. That is them expressing a habit. And that happens after 2 times.
Wow.
So you don't form habits that easily for incidental, mild, positive experiences. And I can tell you that they don't form a habit anywhere. They don't even get close to that kind of a habit for accessing chocolate. So helping the trapped rat out of that restrainer is more rewarding for our rats than is accessing chocolate.
That's great. You've given me optimism about the future.
There's a bad side to it too,
which
is, well, you are going to want to help, and you're going to want to ascribe your actions, ascribe benefit to others to your actions. So I may say, helping feels so good. It's not a cognitive thing, but this is the teleology of it, that I'm going to go help that person get in and out of the car. And that person may be a person that's in a wheelchair, that a person that looks older, and it may very well be that they don't want your help. So you are feeding yourself, because what you're intending to help, and you're experiencing what your actions as a help, and you're getting the rewards from it, regardless of whether it is construed as help by the receiver. And the receiver may find it intrusive. They might find it infantilizing. And in fact, they may not find it particularly helpful. So there's a danger.
All right, I'm going to do a segue to just a slightly different topic here, because I think part of it will have overlap with it. But you are a passionate neuroevangelist, which is the first time I've heard the term.
I coined it, I think.
I think you did. And which aspect of everything you're talking about gave you the craving to, like when a guy like me is looking at your notes, and I started taking your Coursera free course today, and what made you step up to the plate to do that?
I love, for me, the neurobiology of life. From the time I wake up to the time I go to sleep, there's neurobiology the whole way around. I used to remember we spent a long time on this interaction between urination and pain. And, so I learned a lot about bladder and bladder control, and it turns out that the bladder is a very interesting muscle that you can regulate the elasticity of it, so that it feels full at different volumes depending on the elasticity of the muscle. When you wake up in the morning, it's the 5 minutes before you wake up, and at 5 minutes after you wake up, the volume is basically the same. And yet at one moment it feels intolerable, and at another moment you're able to sleep through it and no problem. And I used to experience this as my cat would be on me, and of course, I don't know, I am a very cat person. So if a cat is on me, I can't move, because I don't know, that I just can't. And so, I would just feel my bladder get modulated, where the volume appeared to expand and expand. I knew it's just in your brain. It's not, it's a matter of the central, or matter of the nervous system, I should say, not so much of the volume. And I like just thinking about how neurobiology comes in at every moment of the day, from the time I wake up to the time I go to sleep. When the opportunity came, when the University of Chicago approached me to do a Coursera course, very quickly I realized that this was an opportunity of what I would call, and what Roy Weiss, who got me into this, called educational social justice. So this is providing information and educational resources to individuals, no matter where they are, how much money they have, whether they can travel to Chicago, whether they can pass an entrance exam, none of that matters. What age they are, none of that matters. If they can get an internet connection, they can access this information. And, I don't get that many chances to do good as a professor teaching up to, I'd say, up to 100 people at a time normally. And this is the ability to potentially reach thousands. And I've reached, over 300,000 using this.
How cool is that?
mechanism.
That is so cool.
Yeah, and it's great. And there are other Coursera courses that have reached many more, but I'm pleased. I'm pleased. And it's a weird thing, Hacky, because there is a sense of community, or I feel a sense of community. Perhaps it's a false sense of community, but I feel it, as do others that have taken the course.
That's cool.
Yeah.
Well, your style is very matter of fact, engaging. I just watched a couple of them real quick, so I compliment you on that. Tell us how neurobiology, how you correlate that with neurodiversity, with all of our different kinds of brains, from, like, you had a little bit of a seizure, there's autism, there's Alzheimer's, there's PTSD, there are all these overlapping. Just in my concept of neurodiversity, I put everything under one roof at different brains. The mental health issues, the neurology issues, and the neurodiversity and developmental and learning differences are all there, so I can get the different silos talking to each other. But how do you see it as applies to what I'll call, for lack of a better term, standard neurodiversity terms or labels? Like, people mistakenly say, for instance, those with autism lack empathy, which has been shown to not be true. And I wondered if you had any thoughts on that.
I'll be honest that I haven't thought deeply about neurodiversity. I'm still, I find it interesting. I in general don't take individuals as types. I take individuals as individuals. So I don't think that we're particularly good at explaining why, let's say in 100 patients with Parkinson's disease, and Parkinson's is a good example, because it's an actual disease where it's probably either one entity or just a few entities. It really is a thing. It's a correctly reified thing. But one individual starts with a tremor, another one starts with a bradykinesia, another one starts with an akinesia, one starts in the hand, one starts in the left leg, another one starts in the mouth, whatever. And how does neurobiology, or neurology for that matter, do at explaining those individual differences? I'd give us an F. It's an F. So that's why what physicians are good at, and what scientists are decent at, is to explain the population. That does no that does no good for an individual. And the best approach to this conundrum that I've ever seen or I've ever heard of was an individual who told me about a mother who told me about her daughter who had a very, very unusual, uber rare condition. And the physician said, I'm an expert in this category of neurological issues, but you're the expert in your daughter. If we work together, we can accomplish where we can get to where we need to go. But neither one of us alone is going to make it. And that to me is, I like that approach. I think that's a kind of physician that I would love to have if I were in such a situation. And then the question is, are we all in that situation? Are we all so different and unique? Are we splitters? And if we're enough splitters versus lumpers, is that the human condition, period? In which case it's a situation where physicians need to work with individuals anyway. And to be fair, I think that is the attitude of most physicians, which is everything disappears and it's the person in front of you. That's what they're talking about. That's who they're dealing with. They're dealing with the problems, desires, needs of the individual that they see in front of them. And bringing into bear all this other population information.
How can people learn more about you?
I'm on Twitter as NeuroMooc, NEUROMOOC. I have a blog that's called thebrainissocool.com. That's 2 S's. The brain is so cool. And what else? If you track down my UChicago address, I'll talk back to you.
Okay. And of course,
I'm not going to give it out, but if you track it down, then you're motivated enough.
And your Coursera course, of course.
And my Coursera course is free to everyone. They're going to try to make you pay for a certificate, but you don't have to do that.
Why should people be interested in neurobiology?
People should be interested in neurobiology because you are just a neurobiological animal. That's all you are, no more, no less.
So on that note, Dr. Peggy Mason, Professor Mason at the University of Chicago, neurobiologist extraordinaire, thank you so much for being with us here at Different Brains.
Thank you.
Exploring Different Brains is a production of Different Brains. Visit us at differentbrains.org.